Imagine how gigantic our universe is. It is so expansive, and the scientific community continues to make new discoveries all the time about space and what's out there. The universe is infinite, so the idea that only one of the billions upon billions of planets has life on it is extremely improbable. Earth can't be the only planet with life on it, which means there must be aliens out there somewhere. When I talk about alien life, I'm referring to microscopic creatures, not the little green men we all want to believe exist. Extraterrestrial life has yet to be found, though. So you may be wondering how aliens would live out in space on different planets. Well, here's the way. Water. Water, as you know, is a polar molecule made of an oxygen atom and two hydrogen atoms. As is evident on Earth, water is vital to ecosystems and life processes. Without water, life would not have developed. Without water, astrobiology would likely not have gone anywhere. Now you may be thinking, yes, I know, water is super important, but why? What is it about water that makes it so essential to life that other liquids can't be a substitute? Well, water has unique characteristics that make it essential to living things and therefore essential to life outside of our world. First, water is cohesive and adhesive, meaning its molecules can stick to other water molecules and to molecules of other substances. Without cohesion, the transport of nutrients and water throughout plants would not be possible. Water is also specifically needed for life because it expands upon freezing. This causes the density of ice to be lower than that of water and makes ice float on top of water. The ice is then able to insulate and protect the ecosystems underneath from freezing. In addition to expansion upon freezing, water has a high specific heat capacity, meaning that it takes more energy to change the temperature of water by 1 degree Celsius than it does for other substances. Both that and water's high heat of vaporization allow water to moderate the temperature of surrounding air by absorbing heat without getting as hot as other substances. Last but not least, water is a great solvent. Many types of molecules, compounds, and ions are able to be dissolved in water because of its polarity. Solutions vital to the function of organisms depend on water as a solvent. So, as you see, water cannot be replaced by any other substance we currently know of. Life would not be the same or even possible without water. Everyone knows the evolutionary theory that life on Earth began underwater billions of years ago. The conditions of the water protected the early prokaryotes from the harsh world, and they developed into organisms that carry out photosynthesis, which released oxygen. Eventually, enough oxygen was released to create the Earth's atmosphere. Over 1 billion years, eukaryotes evolved, first protists, and then eventually plants, fungi, and animals. But the point is that without the conditions of the water protecting the early life from the harsh world of early Earth, life would most likely not have begun. If habitable water was found on other planets, the possibility of life there would be even greater. Imagine actual extraterrestrial life. That would be amazing. And it was just our luck that just recently, on September 28, 2015, NASA announced that flowing water was found on Mars. Lujendra Ojha and his colleagues discovered dark streaks on the surface of Mars a while back. These dark streaks were called recurring slope lineae. During the warm seasons on Mars, the streaks would be visible, but during the cold seasons, the streaks would not be visible. They believed the streaks were not visible during the cold seasons because the water had frozen and therefore could not be flowing downhill in these areas. Ojha could not prove that this was water, though, because all they had were pictures. Recently, the team was able to create a new study. They used a spectrometer to examine the infrared light reflected off of the surface in the location of the recurring slope lineae, and they found the infrared light signature for hydrated salts when the dark streaks were present on the surface, but not during the time when the streaks were gone. With this new study, NASA was able to confirm the existence of flowing water on Mars. The worry about the water on Mars is that it will have too high of a salt content for any life to exist in it. One hope is that because the water freezes during part of the year, it will have a low salt content since a high salt content keeps water from freezing. This is evident even on the Earth. There is a pond in Antarctica that is very similar to what scientists imagine water on Mars would be like. Don Juan Pond in Antarctica had such a high salt content, about 10 to 15 times saltier than normal seawater, that it never freezes, even though it is in Antarctica, one of the coldest places on our planet. It never freezes because the huge amount of dissolved salt in the water causes the freezing point to lower. The high salt content is actually caused by water tracks, which are very similar to the recurring slope lineae on Mars. A study from Brown University explained how Don Juan Pond got water. They discovered the water comes from two sources, one of which is melting snow. But that doesn't add to the salt content of the water. However, the second source does. There is sediment near the pond that is high in calcium chloride. At night, the salt absorbs water from the air when it is humid, called deliquescence. This water becomes puddles on the surface and is saturated with salt. Eventually, this water will flow to the pond as water tracks. Since this pond is similar to what scientists believe some of the water on Mars will be like, if life is able to exist in the pond, life may also be able to exist on Mars. About 40 years ago, researchers said they found algae, bacteria, and other small forms of life in the pond. But in recent years, no life has been found within the water there. Humidity-induced deliquescence may be an explanation for how water exists on Mars. As of right now, it is known that little puddles of water form on the surface of Mars at night. The water from the humid air is pulled down to the surface and condenses due to the high salt content of the Earth on Mars. Other locations on Mars also have water. Water is frozen at Mars' poles, deep under the surface, and in the atmosphere of the red planet. But none of these discoveries have meant for the possibility of alien life what September 28th's announcement of flowing water meant. There is even evidence that there were large amounts of flowing water on Mars a very long time ago that could have supported life. Mars rovers have examined rocks, crossed ancient riverbeds, and sent back images of the areas of Mars that once had lots of water. Astrobiologists believe that at some point all this water may have been able to sustain microbial life. But when most of the water evaporated and was then lost to space, the large rivers and oceans disappeared. This same case may be true today on Mars. The flowing water may be able to still sustain life like it was believed to in the past, or some of the microbial life from long ago may still be surviving in certain areas. Life as we know it depends on water. It is protection, regulation, transportation, nourishment, hydration, and the list goes on and on. The discovery of water on Mars, specifically flowing water, brings us that much closer to discovering alien life. And alien life is so important to us as humans. We are reaching our carrying capacity here on Earth, meaning soon there won't be enough resources left on Earth to sustain us. That means finding a place to live other than the Earth will be very important to us in the near future. Hopefully, if aliens are able to survive outside of our world, so will we. So thanks to water, we are alive, and hopefully so are aliens.